Good afternoon, students. Yesterday we have seen Wien's displacement law and its related problems. Today we have to continue with that and started with the new topic. Okay. So now write down the problem. So yesterday we have completed two problems now. So here we have to continue with the problem number 3. So note down the problem. A black body radiates energy at a rate of 1 watt-meter square at a high temperature. Energy they are given in volt by meter square at a high temperature Tk. When the temperature is reduced to T by 2 Kelvin, the radiant energy will be option A, it is E by 16, and option B, it is E by 4, and option C, it is 4E, and option D, it is 16E. So let us now go for the solution. So here the temperature, it will be reduced, that is Tk to T by 2. Okay. For the first one, you are choosing T1, and the second one, it is T2. Okay. So already we are known the formula which is related with energy and temperature. Okay. Solution. Here we know that E, which is directly proportional to T power of 4. Here they are given two temperatures, no? So we have to write down energy value, that is E1 by E2 is equal to T1 divided by T2. This formula you have to use. Okay, right? The whole power 4. So now we are taking the value for T1 is equal to the initial one. So it is T, and T2 is equal to T by 2. Okay. So let us now substitute in this formula. Okay. T divided by T by 2, the whole power 4. Okay, the whole power 4. Either it is written as T power 4 or T power 4 divided by 2 power of 4. Okay. Then for the next step, it is T power 4. Denominator we can convert it into numerator. Okay. Then 2 power 4 divide by T power 4. We just cancel T power 4, T power 4. Then what you will be getting? 2 power of 4. Okay. So that is 2 into 2 into 2 into 2. What is it? It is 16. 4 into 4. It is 16. Right? So here it is E1 by E2. Either we can take it E1 as E divide by E2 is equal to 16. Okay, T1 number we can take it as a E T அப்படிங்கும்போது E1 நம்ம என்ன எழுதலாம்? It is E அப்படின்ட்டு எழுதலாம். So just cross multiplying this value and finally we get the value of E2 is equal to, okay, E2 value is equal to what it is? E by 16. So this is our answer. So this is option A. This is option A is the right one. Okay. Okay, now what is clear? Right. Next, we can go for one more problem. That is problem number 4. The ratio of energy of emitted radiation of a black body at 27 degree centigrade and 927 degree centigrade. Okay. So here they are given the options, that is 1:4, and here it is 1:16, and option C it is 1:64, and D it is 1:256. So let us now choose which one is right. Now I given one clue. Okay, so here they are given the energy, no? Right. The energy value, either we are writing E notation or Q notation, whatever it is right. Either E1 by E2 or Q1 by Q2. Render notations may எழுதலாம். Okay, which should be is equal to T1 divided by T2 the whole power of 4. Okay, now in that problem they are given Celsius value. Okay, you are converted into Kelvin value and then you have to substitute in this expression. Okay, then we can calculate the ratio. Right. Yesterday itself I told you that if you converted the Celsius into Kelvin, Celsius to Kelvin convert பண்றோம் அப்படின்னா you have to add 273 from the given value. Given value ஓட 273 values add பண்ணிக்கணும். Okay. So here it is 273 plus 27 divided by 273 plus 927, the whole power 4. Okay, so that is the step. So you should work out and tell me the answer, which one is right. Okay, it is 2 minutes time. You have to work out. Okay, right, very good. The option is D. So எப்படி வருதுன்னு பார்க்கலாம். So here we have to add the value, that is 300, and here it is 1200. Okay, the whole power of 4. Cancel out the zeros, and this is 1 time and this is 4 time. Okay, 1 by 4, the whole power of 4. Okay, the whole power of 4 அப்படிங்கும்போது 4 into 4 into 4 into 4. Okay, here it is 16 and here it is 16. 16 into 16, 256. Okay, so 1 by 256. So இதை நம்ம ரேஷியோ எழுதும்போது 1:256. So this is option D. Option D is the right one. Okay. Okay, up to this clear? Put it in the comment box. Okay, next we can go for the problem number 5. Right, very good. A body, next problem, a body of area 1 centimeter square is heated to a temperature 1000 Kelvin. 1000 Kelvin. The amount of energy radiated by the body in 1 second. 1 second is how much? That is the question. And here they are given the Stephen constant value. Stephen's constant value. We are very well known that is 5.67 into 10 power of minus 8 watt meter power minus 2 and Kelvin power minus 4. Now they are given the options, that is 5.67 joule, and option B, it is 0.567 joule, and option C, it is 56.7 joule, and option D, it is 567 joule. So this is the question. Okay. So here we have to notice that in that problem they are given the area value. They are given the area value, they are given, and the temperature value they are given. Okay. Then for time value they are given. Time, it is 1 second, and the constant value, that is the sigma value, they are given. Okay, let us now substitute in the formula. We have to calculate the solution now. Okay. So go for the solution. So here we have to use the formula, that is E is equal to sigma A into T power 4 into T. So this is one of the Stevens law equation, right? So in that equation you have to substitute that and give the options. Substitute பண்ணி the given values எல்லாமே நம்மளுக்கு கொடுத்தாச்சு. So substitute பண்ணி போடுங்க பார்க்கலாம். It is A is equal to, here A, it is 1 centimeter square. Centimeters we can convert it into meter. Okay, so per 10 power of minus 4 meter square. Okay, 1 centimeter square, it becomes 10 power minus 4 meter square. Okay, then what is the value of T? T is equal to 1000 Kelvin, and small t value, it is 1 S, and the sigma value, what it is, 5.67 into 10 power of minus 8 watt meter power minus 2 and Kelvin power minus 4. Okay, so let us now substitute all the values. Okay, so here we have to take the formula, this one, and substitute all the values. Okay, so substitute பண்ணுங்க, it is 5.67 into 10 power of minus 8 into area value, it is 10 power minus 4 into, for temperature it is 1000 into time, that is 1. Okay, right? Then it is 5.67 into 10 power of minus 8 into 10 power of minus 4. Okay, here the temperature, the whole power 4. Okay, so 1000 we are writing 1000 we are writing 10 power of 3. 10 power of 3 அப்படின்னு சொல்லிட்டு நம்ம எழுதுறோம். Okay, so it is 10 power of 3 the whole power 4. Okay, into 1. So let us now 5.67 into, here it is minus 8 and minus 4. Okay, minus 8 and minus 4, it becomes minus 12, and into 10 power of, here you have to multiply the value, that is 10 power of 12. Okay, Then for the next step, you cancel plus 12 and minus 12. Then what is the remaining value? That is 5.67. In that problem, we are taking the energy value. So energy value always given in joules. Okay, right. So this is option A is the right one. Okay. Next, we can go for the easiest problem, which is related with the formula. If you know the formula, you just tick it the answer directly. Okay. So here it is the problem number 6. A black body is at a temperature, it is 300 Kelvin. Yet emits energy at a rate which is proportional to the options are A, it is 300, and B, it is 300 the whole square, and C, it is 300 the whole cube, and option D, it is 300 the whole power 4. Now tell me which option is apt for this one. Yes, it is option D. So here, which formula is work out? என்ன formulas நம்ம யூஸ் பண்றோம் சொல்லுங்க பார்க்கலாம். So in that problem, they are given the given one clue, that is the black body. Okay, so black body abdinave, we can keep in mind that the laws, that is Wien displacement law and Stephen's law, ரெண்டு laws-ல இருந்து தான் ஏதோ ஒன்று வரணும். Okay, so for temperature மட்டும் தான் they are given அப்படிங்கும்போது directly we can go for the temperature and energy, it is Stephen's law. Okay, right. So here we are using the formula E is equal to sigma into T power of 4. Okay, here sigma, which is nothing but it is the constant. So here E, which is proportional to T power 4. So per T oda value, here it is 300. So apna varum 300 the power of 4. Right? So the option D is the right one. Okay, up to this clear? Comment box la podunga paakalam. இது வரையிலும் போட்ட ப்ராப்ளம்ஸ் எல்லாமே I have to do. Yes, very good. So these are all very simple problem, but now we are dealing with the easiest and toughest. Okay. Right. Next problem number 7. If the temperature of a hot body is increased by 50 percentage. Okay, then the increase in the quantity of emitted heat radiation will be option A, it is 125 percentage, and option B, it is 200 percentage, and option C, it is 300 percentage, and option D, it is 400 percentage. Okay, here they are asking the increase in quantity. Okay, increase in energy we have to calculate. And the increasing energy we are having one formula. Okay, and the formula la number values substitute panni final result kondu varom. Okay, right? Let us now solve this one. So now go for the solution. I already told you that the energy value which is equivalent to Q value. Okay, so either we have to represent it as E or Q. Which one is right? Abdina, both of them is right. Energy வந்து நம்ம Q லியும் represent பண்ணலாம், either E லியும் represent பண்ணலாம். Okay, so here also we are using the same formula, that is E, which is directly proportional to T power of 4, or Q, which is directly proportional to T power of 4. Okay, so let us now write down the formula. Okay, so in that problem they are asking increase in energy, that is the percentage increase in energy they are asking. Okay, hot body or temperature, it should be increased 50 percentage abdina energy amount evlo increase agum, that's question. Okay, so increase in energy calculate பண்றதுக்கு we are writing first the formula. What is the formula? That is Q2 minus of Q1 divided by Q1 into 100. Okay, right? Q2 minus Q1 divided by Q1 into 100. So in the values la da நம்மளோட ரிசல்ட்டோட வேல்யூஸ கொண்டு வரணும். ரைட்டா? So அதுக்காக we are choosing this equation. Okay, either we are writing E form or Q form, the equation it should be right. E nu represent பண்ணலாம், Q nu represent பண்ணலாம். So இந்த ஃபார்முலால எல்லாமே Q notations தான் இருக்கனால, எல்லாமே Q அப்படின்றது இருக்கனால we are choosing this formula. Okay, we are choosing this formula. So let us now write it the formula that is Q1 by Q2 is equal to Q1 by Q2 is equal to T1 by T2, the whole power of 4. Okay, right? So here the initial temperature, it is T. Okay, then the initial temperature, that is T, and it will go some time, it will be increasing 50%. That is, you have to add the initial value, right? Huh? So what is the initial value? It is T. T order half the value, it should be increased. So T by 2 order value, it should be T plus T by 2. Okay. So let us now substitute T value, T1 value and T2 value here. Okay. So T divided by T plus T by 2, the whole power of 4. Okay. So here 1 is a half, 1 and half, 1 plus half, 1 and half, that is 3 by 2. Okay. So T divided by 3 by 2 into T, the whole power of 4. Okay. So here we have to cancel out TT. Then Q1 by Q2 is equal to Q1 by Q2 is equal to, here it is 3 by 2. Okay. Here it is 3 by 2. Now we are converting into the above. Okay. Denominator we can convert it into numerator. So potom dina, it is 2 by 3. It is 3 by 2 enama change agum. It is 2 by 3 change agum. Okay. The whole power of 4. Okay. Let us now Q1 by Q2 is equal to 16 by 81. 16 by 81. So in the Q2 oda value என்னது? So நம்மளோட formula first quantity என்னது? Q2 தான் first தேவை. So அதனால இந்த equationல இருந்து we have to calculate the Q2 value. Okay. So Q2 value is Q2 values தான் வேணும். Okay. So in the Q2 oda values you just cross multiply this one. Okay, cross multiply this one, and here it is this one. So cross multiply pannona, we are getting Q2 value is 81 Q. Okay, 81 into Q1 divide by 16. In the 16 நம்மளுக்கு கீழ வந்துரும். It is 16. Okay. So இப்ப Q2 oda values we are known. Okay. So இப்ப இந்த formulaல substitute பண்ண வேண்டியதுதான். Okay. Q2 oda values தெரியும். Q1 values as such அப்படியே வச்சுக்கோங்க. Okay. So substitute பண்ணி solve பண்ணி எனக்கு என்ன answer வருதுன்னு சொல்லுங்க பார்க்கலாம். So up to this clear? Q2 oda values கண்டுபிடிக்கிறது எல்லாருக்குமே தெரியுதா? Put it in the comment box. Okay. Q2 oda values என்னால calculate பண்றதுக்கு எனக்கு தெரியும் அப்படின்றவங்க மட்டும் கமெண்ட் பண்ணுங்க. Up to this I am clear. Okay. Right. So இப்ப formulaல we are known the value of Q2. Okay. Q2 oda values நம்ம find பண்ணியாச்சு. இப்ப இந்த வேல்யூஸ நம்ம என்ன பண்ண போறோம், இங்க கொண்டு போய் சப்ஸ்டிட்யூட் பண்ண போறோம். Okay, so that is the next step. So write it down. It is, what is the value of Q2? It is 81 divided by 16 into Q1 minus of Q1 divide by Q1 into 100. Right? So we have to take it out the value of Q1 outside. Q1 வெளியில எடுத்துறோம். Okay, so it is becomes 81 divided by 16 minus of 1. Okay, ரெண்டோட இதுல இருந்தும் நம்ம காமனா Q1 we have to take it out. எடுத்தாச்சு into 100 கீழ divide by 1 Q1. Right? So next step you have to cancel this one. Then நீங்க next step என்ன பண்ணணும், cross multiply பண்ணணும். So இப்ப cross multiply பண்ணோம்னா it is 81 minus of 16 divide by 16 into 100. Okay, then 65 divide by 16 into 100. Okay, so it is nearly 4 times, no? 16 into 4, that is 64. Okay, so approximately we have to, approximately it is 4 point something varum. So we just if you go for the option, all of them in whole numbers, right? It is 125, 200, 300 and 400 percentages. Okay, there is no decimal points, so adanal whole numbers oda we have to stop. சரியா? So 4 into 100, 400. Okay, that is 400 percentage. Okay, 400 percentage. So that is the right one. So that is the option D. So this is option D is the right one. Okay. Right. Next we can go for the next topic, that is Newton's law of cooling. So in the mari இதே same problem liye they are given the values, either the hot body oda temperature it is increased by 3 times. Okay, 3 by 4 times அப்படிங்கும்போது we have to substitute T2 values la anga poite change in values substitute பண்ணிட்டு இந்த same problem work out பண்ண வேண்டியதுதான். Okay, so இந்த மாதிரி இந்த problem கேக்குறதுக்கு நிறைய chances இருக்கு. Okay, next one, Newton's law of cooling. So cooling அப்படினாவே, so when a body is cool அப்படினாவே it will loses the temperature. Okay, so simply we are take it a hot body, that is a coffee. Okay, so coffee, it should be a hot liquid. Initially we are taking, okay, at a temperature T1. Okay, so T1, which is nothing but it is the initial temperature. Initial temperature we have to choose an. Okay, after some time After some time, if you retain the coffee, நம்ம காஃபியை எதுவுமே பண்ணாம அப்படியே as such விட்டுட்டோம் அப்படின்னா it releases the heat energy. Okay, it releases the heat energy, releases the heat or transfer the heat to the surrounding. Surrounding and the heat என்ன பண்ணிடும், it should be transferred. Okay, so after that, after some time, after a certain time, it gets cooled. Okay, so initially hot temperature இருந்தது, the temperatures எல்லாமே heat energy எல்லாமே release ஆனதுக்கு அப்புறம் இந்த particular coffee ஓட temperature it should be reduced. Okay, that is we can take it as a T2. Okay, the change in temperature we have to take it as T2, right? So now you have to answer this question. Either T1 oda value increase ah irukuma, T2 oda value increase ah irukuma. Which one should be as a higher temperature value? Either the initial one or the final one. T1 oda value அதிகமா இருக்குமா, T2 oda value அதிகமா இருக்குமா? Either T1 is increases or T2 is increases. சொல்லுங்க பார்க்கலாம். Which one is greater? Yes, T1 is high. So T1 is greater than T2. So on that time, what is happening? The heat energy is exchanged between the surroundings. Okay, so the rate of cooling value, it mainly depends upon the temperature difference. Okay, so here the temperature difference between T1 and T2. So the cooling value mainly depends on temperature. Okay, then nature of the surface. Okay, and the surfaces we can keep அப்படின்றத பார்க்கணும். So initially we have to take it the coffee in a simple ceramic cup, or it should be as a silver tumbler or aluminum tumbler. Okay, so idla moonlime we have to take the same quantity. Okay, same quantity of a hot liquid. Okay, some amount of energy it should be withstanding different kinds of three vessels. Okay, so having here it is 3 vessels. Here it is a ceramic, the material, and here it is that is aluminium. It is made up of the vessel, it is aluminium, and here that is the silver coating. Okay, so different kinds of vessel we are chosen. Okay, the same quantity of heat it should be taken, same quantity of hot liquid you have to choose then. Okay, so the rate of cooling it will be same for all the 3 or it will be different. The rate of cooling process வந்து எல்லா மெட்டீரியல்லுமே ஒரே மாதிரி இருக்குமா, or it should be differ இருக்குமா? That is the question. Yes, it is different. Okay, the cooling amount, the rate of cooling amount, it should be different. So the cooling effect, it will depends on the nature of the surface of the body. Okay, nature of the surface of the body. அதையும் depend பண்ணிருக்கும். Then particular area. So a small cup or large cup ரெண்டையுமே எடுக்கிறோம். Okay, அதே same amount of liquid. ரெண்டு கப்லயும் choose பண்ணும்போது எது ஈஸியா சீக்கிரமா கூல் ஆகும். So quantity wise it should be differ அப்படிங்கும்போது that is a small cup and larger cup. So the area is also important one. So the rate of cooling value, it depends on the area and the nature of the substance and the temperature. So the ellame you are keep in mind. Okay. Right. So in the same quantities எல்லாம் இருக்க மாதிரி we are having one question. Okay, so here I will give one example. That is the rate of cooling. The rate of cooling of a body depends on first one, the difference of temperature of the body and the surrounding. And second option, it is the area of surface of the body. And option C, it is the nature of surface of a body. And option D, it is all of these. So let us tell me the correct one. So very good. It is option D. So இதுல concept தெரிஞ்சா மட்டும்தான் இந்த questionக்கு you have to answer. இல்லனா என்ன போடுவீங்க? A option போட்டுட்டு போயிட்டே இருப்பீங்க. A option correct தான். But area and nature of the materials you should know. Okay. Right. So let us now go for the formula for Newton's law of cooling. Okay. So here we can calculate the rate of change of heat energy. Okay. The rate of change of heat, that is dq divided by dt, which is proportional to T1 minus of T2. Okay. So this is for one body with the surrounding. Okay. So the temperature changes is between one body and the surrounding. Suppose two bodies நம்ம choose பண்றோம். Two bodies எடுத்துட்டு அதிலேந்து some amount of heat energy surrounding க்கு transfer ஆகுது அப்படிங்கும்போது we are using the next formula. Okay. for two body and surrounding. One body we are writing this one, and the second body ரெண்டு bodies கொடுத்து அதோட surrounding temperatures கொடுத்தாங்க அப்படின்னா நம்ம எந்த ஃபார்முலாவை சூஸ் பண்றது? that is T1 minus of T2 divided by T is equal to K into T1 plus T2 divided by 2 minus of TS. This is the formula. Okay, right? So here T1 அப்படின்றது என்னது அப்படின்னா this is a starting temperature or initial temperature, and T2 it is the ending temperature or final temperature. Then here small t it is time, small t it is time, and K it is a constant value. Okay, and TS which is nothing but surrounding temperature. Okay, so இத வச்சு தான் நாம என்ன பண்ண போறோம்? Problems work out பண்ண போறோம். Suppose two bodies with the surroundings கேட்டாங்கன்னா we are using in that equation. So previous years Neetல இந்த Newton's law of coolingல இருந்து நிறைய questions வந்திருக்கு. Okay, so இந்த problem எப்படி work out பண்றது அப்படின்றத பார்க்கலாம். So first last year கேட்ட ஒரு question பார்க்கலாம். Okay, so last year கேட்ட question. So write down the problem. A cup of coffee cools from 90 degree centigrade to 80 degree centigrade in T minutes. In T minutes, when the room temperature is, when the room temperature is 20 degree centigrade. The time taken by a similar cup of coffee to cool from 80 degree centigrade to 60 degree centigrade at a room temperature. At a room temperature same at 20 degree centigrade. Yes, the option A it is 13 by 10 into T, and for option B it is 13 by 5 into T, and option C it is 10 by 13 into T, and option D, it is 5 by 13 into T. Okay. So here we noticed the similar cup, but the change in temperature for the first case is 90 to 80. Okay. Here they are given the room temperature, that is TS, surrounding temperature. No, okay, surrounding temperature, that is here it is TS. Okay. So here T time la. Okay. T time la. It changes the time, that is 90 to 80 convert agudhu. Okay. That information they are given, right? Then the time taken by the similar cup of coffee to cool from. So 80 convert ஆனதுக்கு அப்புறம் திரும்ப 80 ல இருந்து 60 டிகிரிக்கு 80 ல இருந்து 60 டிகிரி வரதுக்கு how much time it takes? Okay, that is the question. Okay, so 90 ல இருந்து 80 க்கு கன்வெர்ட் ஆகும்போது it takes t time, and 80 ல இருந்து 60 க்கு சேஞ்ச் ஆகும்போது எவ்வளவு டைம் எடுத்திருக்கும் அப்படின்றத கொஸ்டின். ஓகே, ஸோ கூல் ஆகும்போது நம்மளுக்கு ரேட் ஆஃப் கூலிங்கோட வேல்யூஸ் எப்படி சேஞ்ச் ஆகுது அப்படின்றதுதான் கொஸ்டின். ஓகே, ஸோ இந்த ப்ராப்ளம்ஸ சால்வ் பண்றதுக்கு நம்ம எந்த ஈக்குவேஷன் எடுத்துக்கலாம்? எய்தர் ஃபர்ஸ்ட் ஈக்குவேஷன் ஆர் செகண்ட் ஈக்குவேஷன். எந்த ஈக்குவேஷன் சூஸ் பண்ணிக்கலாம்? சொல்லுங்க பார்க்கலாம். Either the second one. Okay. So now go for the solution. So in that problem, they are given the data, that is 90 ல இருந்து 90 degree centigrade ல இருந்து என்னவா கன்வெர்ட் ஆகுது? 80 degree centigrade கன்வெர்ட் ஆகுது. Okay. Then இதுக்கு எவ்வளவு டைம் எடுத்துக்குது? It is the time T. Okay. So this is the first case, first one. Okay. Next, இதே same cup 80 degree ல இருந்து it will be cooled and it becomes 60 degree convert ஆகுது. So initially இதோட time T அப்படின்னு எடுத்துட்டோம்னா for the second caseக்கு எனக்கு how much time it takes? Okay, second time convert ஆகிறதுக்கு எனக்கு எவ்வளவு டைம் எடுத்துக்குது? That is the question. Okay. So இப்போ நம்ம ப்ராப்ளம்ஸ்க்கு given values லாம் எடுத்துக்கலாம். So இதுல first step you have to solve first portion, and first portion is carried out between 90 to 80. Okay, and the second one is carried out by the temperature, that is 80 to 60. So this is the second case. Okay, first one நம்ம solve பண்ணலாம். So for the first one, we are write down the T1 value, that is 90 degree centigrade. And what about the T2 value? It should be is equal to 80 degree centigrade. And what is the TS value? It is a surrounding temperature or room temperature. That is 20 degree centigrade. Right. For the first one, what is the time taken? It is T. Okay. So in the informations எல்லாமே நம்மளோட given formulaல substitute பண்ண போறோம். So what is the formula? It is T1 minus T2 divided by T is equal to K into T1 plus T2 divided by 2 minus of TS. So this is our formula. இந்த ஃபார்முலால நம்ம ஃபர்ஸ்ட் கேஸ்க்கு மட்டும் தான் என்ன பண்ண போறோம்? இந்த வேல்யூஸ அப்ளை பண்ணி changes ஓட values நம்ம calculate பண்ண போறோம். Then afterwards என்ன பண்ண போறோம், second case க்கு values calculate பண்ணிட்டு ரெண்டு valuesல இருந்துமே finally how much time it takes to cool from 80 to 60 அப்படின்றத we have to calculate. Okay, so இப்ப இந்த datas வச்சு நம்ம first ஒன்னுக்கு என்ன பண்ண போறோம், equation calculate பண்ண போறோம். Okay, so let us now substitute the value, that is 90 minus of 80 divided by t, which should be is equal to k constant value, that is 90 plus 80 divided by 2 minus of 20, minus of 20, right? So இதுல இருந்து 90 minus 80, it is 10 by t, and here k, and 90 plus 80, it is 170 by 2 minus of 20. Okay, then for the next step, 10 by t, which should be is equal to k into 85 minus of 20. Okay, so we are getting 10 by t or a value, it is k into 65. Okay, so in the equation, first changes ஓட equation, temperature 90 ல இருந்து 80 cool ஆகும்போது நம்மளுக்கு கிடைச்சிருக்கக்கூடிய expression. Okay, இப்போ நம்ம என்ன calculate பண்ண போறோம், second portion க்கு calculate பண்ண போறோம். இந்த second portion is between the temperature what, that is 80 ல இருந்து 60 வரைக்கும், 80 ல இருந்து 60 வரைக்கும். Okay, right? இப்போ second இதுக்கு நம்ம போட போறோம். So in the first equation we need, இந்த first equation நம்மளுக்கு தேவை, கடைசியா last step work out பண்ணும்போது, so இத கரெக்ட்டா நோட் பண்ணிக்கோங்க. Okay, so this is equation number 1. Then let us now for the second one. Second one க்கு what is the condition, 80 degree ல இருந்து it should be reduced to 60 degree, 80 degree ல இருந்து cool ஆகி 60 degree க்கு convert ஆகும்போது what will be the temperature, அதுதான் நம்ம calculate பண்ணணும். Okay, so அதுக்கு T1 ஓட values என்னது, it is 80 degree centigrade, and T2 ஓட value it is 60 degree centigrade, and TS ஓட values என்னது 20 degree centigrade. Okay, so let us now substitute directly in the formula, that is 80 minus 60 divided by T is equal to k into 80 plus 60 by 2 minus of 20. Okay, right? So here it is 20 by t, which should be is equal to k into, here it is 140 by 2, that is 70 minus of 20. Okay, so here we have to minus na k into 50, that is 20. The change in temperature here we have to calculate, that is T2, no? So you put T2. Okay, T2. So let us now cancel this one. This is 2 time and this is 5 time. So finally here it is 2 by T2. By T2 is equal to k into 5. So this is equation number 2. Okay, for the next step, dividing 1 and 2. Okay, dividing 1 by 2. What you will be getting, that is 10 by t divided by 2 by T2, which should be is equal to 65k divided by 5k. Okay. So we just simplify this one. K it is cancelled. It is 1 time and it is 13 time. Okay. For the next step, 10 by t, we have to write it as such, and denominator values we can convert it into numerator. So just to reverse it, you have to write it down. So T2 divided by 2 is equal to 13. Okay. Then this is 1 time, this is 5 time. Okay. So 5 by t into T2 is equal to 13. So we are need of T2. T2 தான் நமக்கு தேவை. Okay. So T2 மட்டும் தேவை அப்படிங்கும்போது இத ரெண்டையும் நம்ம என்ன பண்ணலாம்? We have to take it out in the opposite side. So but opposite side வரும்போது it should be reversed. So 13 into t divide by 5. So this is option this is option 2. That is B. This is option B is the right one. Okay, so 13 by 5 or 5 by 13 ஆனு கரெக்ட்டா பார்க்கணும். ரைட்டா? So this is option B is the right one. Okay, option B is the right one. Okay, up to this clear? எல்லாருக்குமே இந்த problems it should be okay to solve. Yes, it is easy. Yes. Okay, I will give you one more problem for your practice. Okay, you should try it and put it the answers in the comment box. Okay, so the same formula and the same methodology you have to do the problem. Okay, to solve this problem. So I just give you the problems and options alone. You just work it out and given the options. Okay, from the next class I have detailedly work out the problem. Okay, so now I will give you the problems and its answers. Okay, write down the problem. A hot liquid in a beaker cools from 80 degrees centigrade to 70 degrees centigrade in 2 minutes. In 2 minutes, if the surrounding temperature is 30 degree Celsius, then the time taken taken to cool from 60 degrees centigrade to 50 degrees centigrade is water. Okay, so let us now try, and the answers are, it is 2.6 minutes, and B, it is the 3.6 minutes, and C, it is 5.6 minutes, and D, it is 4.6 minutes. Okay, work out this problem and put the answer in the comment box. Okay, so the simple logic is, I will give the idea alone. So the temperature variations for the first step is 80 to 70, and the temperature here it is 2 minutes. Okay, so this is for the first case, and here they are given the TS value, it is 30. Okay, so this is the first step. And second step, the temperature variations is from 60 to 50. Okay, 60 to 50. So how much time it takes? Okay, so that is the question. So the same methodology you have to do it. Okay, we have to use the second formula and substitute all the values and divide one over the other. Okay, 1/2 values are divide panning appadina, we are getting the result. Okay, you just try it. Okay. Yes, Sonia, Vidya, very good. So others also, you have to do that. Okay, so the same problem, I have to work it out in the next class. Okay, otherwise you just try it. Okay, up to this clear, children? Yes. Okay, thank you. Meet you on Monday. Okay, thank you. For T1 and T2, that is the surrounding temperature, it should be the same.